Alright, hi and welcome back. This is going to be part 2 of assembling the Reprap Wilson II 3D printer. And this is actually an updated version of this segment of the video series because I have made some changes to the design that kind of necessitates that when you build the x-axis you do a couple extra steps. And the reason is because I've eliminated the servo and those components that were used to probe the bed position, and instead I've incorporated those parts into the x-axis. So if you're building a machine that is based on the new updated parts, then this is the video that you want to watch. So like I said, this is going to be the assembly of the x-axis. So I have here in front of me the parts that you'll need. I have the two 10mm smooth rods for the x-axis. They're about 370 millimeters long, and anything really between about 350 and 380 is going to work for those. You'll see why. And then I have the printed parts for the x-axis, which is the idler end and the motor end, the X-carriage, and then the belt tensioner. Has a little X printed on it. That's how you know it's the one for the x-axis. And I have this two-piece belt guide. And then I have these two parts for doing the z-axis probing. So this is the Z rack, and then this is the Z pinion part. And then I have the linear bearings for this step, and one of the stepper motors, two of our end stops, and then nuts and bolts and other fasteners. And there's a checklist and kind of a step-by-step that will follow along with this video that I will put on GitHub, and I'll put and then you can refer to that as well. So to get started, I'm going to get the two X ends and the linear bearings, and each X end has this cylindrical hole through the base, which is for holding the linear bearings. And I'm just going to insert the two into each one. These will only go in from one side. The top side, which is actually the bottom when it's mounted on the printer, has a little flange so that the bearing can't make its way out of there. So you just insert these two from the other side, and they should go in pretty easily. If you have trouble getting them in, what you might want to do is get like a C-clamp or a wood clamp and put the bearing against the end, and then use the clamp to press that into place. Don't try to hammer it or do anything that might damage the bearing or the plastic part. And then the X-carriage also needs linear bearings, and it gets 4 of them, 2 in each of these. And these should go in on either side, but you might find that one side is easier than the other. And these are a little tight. Alright, so those are all in place. Alright, now with the fasteners that we have for this step, there should be 2 of these lead screw nuts. They're usually brass, they might not be. And each one of these attaches to one to each X end and that's what's used to guide our lead screws later on. So just pop that in from this side, so the flanged part is on what will be the bottom, and then use two M3 by 14 millimeter screws. Screw that side, and then a nut, an M3 nut on the top. There's 4 holes in each one, but you'll be fine with 2 screws in each one because they don't experience hardly any torque. Okay, next I'm going to assemble the tensioner. So this little Y-shaped piece is the tensioner, and if we get the 2 belt guides and a 624 bearing, this is a real simple mechanism. The bearing goes between the 2 and then fits into there, and you secure it with an M4 screw with an M4 lock nut on this side, and so that you don't tighten that yoke down. This has to be able to spin freely. And before I attach that, I want to also mention there's also these idler pulleys that you can get. This one is made out of Delrin, but there's also aluminum versions of this, which is basically the same bearing inside, but it's a single piece, and it has better wear than the 3D printed ones. So this is an option for some people. The only catch is this doesn't fit inside these tensioners the way they were originally designed to use these printed parts. But there's an alternate version of this that I put on GitHub that's just the same thing but a little bit wider, meant for these. So if you have these and you want to use them, just look for that model. So I'll put a lock nut on here. And then I'm just going to tighten that just far enough that the threads from the screw come through the lock nut, but it's still nice and loose. Then on the other side is the part of this piece that's going to act as our belt tensioner. And it's a real simple mechanism. I'll show it to you in a sec, but get an M3 nut, and it fits into this tiny little slot, and then a 30 millimeter M3 screw, or about 30 millimeters. It doesn't have to be precise. And just hold that nut and thread that through just until that screw starts to come through there. And then get the idler end, and holding it oriented like this, the belt tensioner just fits right into there. There's 2 little grooves inside here that it's supposed to kind of slide between to keep it from pitching up and down. And then we'll put another M4 by 20 millimeter screw through this side, and that goes through that slot in the middle of the tensioner piece. And then we put a regular M4 hex nut on this side. This one doesn't have to be a lock nut. There's a little recess, a little nut trap built into this side, so it's should fit right down into that. And now the belt tensioner, see how it slides back and forth just a little bit, maybe a centimeter or so. When we turn this screw, what that does is it pushes the end of this screw against this M4 screw, and that has the purpose of pulling this whole piece outward. So we'll attach our timing belt later with it in this position, and then we just turn this screw with a screwdriver in order to pull it back, and that'll give us all the tension that we need on our belt. Now get your 2 end stops, and these are already, I've wired them up, but if your end stops aren't wired up yet, then do that at this point. And you'll want, the one that we're using for the x-axis can be shorter, it can be maybe 40 centimeters. The one that we're using for the z-axis, which is going to attach to our little rack and pinion mechanism, needs to be longer, so I have it at about 70 centimeters. And part of that depends on how you route the wires back to the electronics, but you're going to need this one to be a little longer. So on the motor end, on the X motor end, is going to be where that first end stop goes, and it mounts to this little piece that sticks out here. And I'm going to orient the switch like this so that this is the way it'll be mounted on the machine. So the lever arm will point down, and it just should extend just beyond the plastic here. And in the past I've suggested, and you still can use 2 M2 screws to just attach this, but what I've started doing, which I actually like a lot better now, is using one of these real small nylon zip ties through one hole and through the end stop and then back. And the reason I like this is because if you ever need to take this switch off, or say the wiring here comes loose for some reason, once the machine is assembled, this is right behind one of the smooth rods, and it's a real pain in the butt to get to. And with this end stop mounted with the zip tie, we can just clip that zip tie and take the thing off without having to disassemble our whole machine. And it holds really nicely. It's not going anywhere. I'll just trim that off later. Now our other end stop is going to mount to this Z pinion piece. So this is a kind of a funny looking little thing, and you'll find that one side, you see the 2 holes that are mounted, that are meant for mounting the end stop, and one side has a little ridge right behind it. Behind the 2 holes, that ridge is there in order to block our end stop, to give us even a more secure position for that, so that it can't slip around over time or due to being pushed against the bed a lot. And this one is meant to be mounted also with one of these little 2mm wide zip ties. And if you insert it from this side and then back through, the side here has a groove that's printed into it so that the zip tie actually is going to pull into the part. And I got my zip tie turned around, and then it's gonna not, it's not even gonna stick out above the plastic of the printed piece. Alright, like this. And then try to position the buckle from the zip tie as close as you can, and trim this as short as you can get it, because you don't really want anything sticking this way. You don't want this to stick below the level of this edge here, which will make more sense later. Now this piece is gonna pivot a lot. It's gonna pivot every time this mechanism is used, and for that reason there's a little slot that's built into this right here that is meant for giving some strain relief to these two wires. So and you might actually be able to use this same zip tie that we use to secure the switch itself, but I don't really like to do that. So I just kind of push these two wires in a little, and this goes right up through that hole. Alright, so now the two wires, any pulling against this wire here, you can see doesn't put any strain on the solder joints where these wires are tacked onto the in-stop. Because if they do, if it does this a lot right at that solder joint, it'll break after just a dozen uses or so. And then I'm just going to get my wire cutters and go around and clip these off. Get this one too. Okay, now the next step is get our X carriage, and actually let me mention real quick because I just noticed this. This part has these little supports that are built in so that it's printable. When it prints like this, these overhangs need a support, and that support is meant to be just trimmed off afterwards. So if you have a little bit of piece of plastic there, trim those off so that both of these slots are accessible. Your timing belt later is going to go down through this groove like this, and so it needs to be able to go around this little piece. Anyway, get the Z-rack part, and you'll notice on this that on one side, on the top, embossed is a little X minus and an arrow, and that's just meant as a guide to tell you that side should point towards the home position for the X-axis. So the home position for the X-axis is to the left, and this is the front side of the X carriage that should face you, so just insert this guy with the teeth of the rack down with the left side there. Now I'm going to attach the pinion onto our rack, and the direction that this should face is with the switch up like this little foot that sticks off to the right here from the side you're seeing is going to go towards that same home position side of the X-axis. And if you look down through here, you can see these grooves in the Z-rack. You want to align this little sharp edge, this pointy end, should be fit directly into the very first notch of that Z-rack when this switch is at 90 degrees, meaning pointing straight up away from the X carriage. It might take a couple times here because this one's a little tight fit. Just like that. So see how the pointy end of this is sticking right into that first groove, and if we rotate it, it rotates out and then back in. But to keep this in place, we'll need a screw through there. So I have a 20mm M3 which goes through this hole, and then on the other side is recessed in a little nut trap for an M3 nut. There it is. Just like that. And don't over tighten this or you'll squeeze down on the pinion and it won't move freely. So at this point you should be able to move this rack back and forth and our pinion will move with it. It won't slip. And it shouldn't be too hard to move back and forth. Now if it requires very much force at this point, I would stop and take these off and maybe take a hobby knife or something and clean up any ridges that are on the plastic, or sand it down a little bit maybe with a piece of emery paper or an emery board, just to try to get this so that it should just glide real nicely. Now there's two springs that are going to actually provide some help to us on this. They're tiny little extension springs. They look like this. They're only about 5/8 of an inch long when they're in their normal state like this, and they stretch out to about an inch. And the way that's going to work, let me zoom in here. Is you take a M3 by 10 millimeter screw and put that through one of the loops of our extension spring, and then put that screw through this little hole that's built into the X carriage. Oops. Trying to do this from an angle that you can see what I'm doing. And then screw that in until that M3 screw, you'll feel it just bottom out when it gets close, right there. So you're not trying to tighten that in and punch through the plastic. That's just there to hold that extension spring. And then we're going to do the same thing on the other side with the other spring. So another 10 millimeter M3. And then you'll need an M3 by 40 millimeter screw, so longer one, that you're going to put through one of these extension springs. Doesn't matter which side you start on, I don't think. And then put that through that hole right through the middle of the pinion, like that, until it comes to the other side. And then stretch this extension spring out and put that loop over the other side of the screw, and then put an M3 lock nut on there so that it can't work its way out. And tighten that down just far enough that the threads of the screw come through the lock nut. Should be able to push that 40 millimeter screw back and forth a little bit to kind of center it like that. Now the reason we did all of that is because now these springs should help pull. It's going to pull our pinion into either this position or that position. The idea is that we don't want the machine to end up like in a position like this. So that's why it's nice before you put the springs on, you want this mechanism to be fairly smooth and easy to move, so that the spring can drag it into one position or another. So this is going to work once it's mounted on our machine, is pushing the X carriage into one X end, which is these little blocks that are at that stick out past the end. It's going to hit one of those to raise that up, and then we'll go to the other side, hit the other one to raise it back down, and that's how we will be able to probe the offset and the level of our print bed. Okay, now I'm going to get my motor end and my motor, the stepper motor that I'm using for the x-axis, and I'm going to put the pulley on here first. So this is a GT2 pulley. It's a 20-tooth pulley, which is what I always use, but you can get 16s are also nice. If your motor has a flat side to the shaft, make sure you align one of the set screws of the pulley with that so that it will not be able to turn and slip. And then I'm going to mount the motor onto the motor end. See, I'm going to turn it around so that the leads will go into what will be the down direction. And then using 3 M3 by 14 millimeter screws, I'll just attach those two parts together. Now the teeth of your pulley should line up with this little slot that goes through the motor end. See how mine's out a little too far on the shaft. That's why I turned it around when I put it on the shaft so that the teeth can get where they need to go. So I'll just loosen the pulley up a little bit here. And probably putting the motor on onto the X end before mounting the pulley would have been a smart idea. Okay, so that's where the timing belt for our X-axis will go through there. Motor will turn, pull our X carriage back and forth, and everything will work. Now the last thing that we do with all of these respective parts is we get our 2 smooth rods and just put a smooth rod into 2 receiving holes on one of the X ends. And the receiving holes that are built into these go relatively deep, which is why the actual length of your X end rods is fairly flexible. You can, as long as you have the minimum, which I think is around 340, to the maximum, which I think, if I remember right, is around 390. Anything in between there pretty much will work. Now get the X carriage and holding it so the arrow side is pointing up and is towards you. Just slide that on, and be careful here that you don't force this into place at a crooked angle and knock the little tiny ball bearings out of your linear bearings. I have done that. And put the other X end on. Like that. So that's our X-axis pretty much. And I'm gonna attach here on the motor end. The wires coming off of our end stop are kind of vulnerable at this point because they don't have any strain relief. So there's a little slot built in here again that I added just for that purpose. So give the wire a little bit of a push like that, and then tighten that down. So now there's a little bit of the wires have no real force on them. And then around on this side down here, there's another one of those. Actually, there's a third one right here, but I'm not going to use that. But this one that's on this side is meant to hold both these wires so that they will stay out of our way, as well as some strain relief for the motor wires by looping them around like this. And if you're wondering if this stuff really matters, I really think it does, because after you've had a machine that's actually in use, and especially if you're using it a lot, after a few months, these little things like cable guides and strain relief make a huge difference in how many headaches you have fixing your machine. So that's what that should look like. So now these wires will actually go backward away from us, from this view back to the electronics, but now they're nice and held. Alright, now we aren't going to put the timing belt on because the two X-ins kind of float on these rods, meaning I can pull them out or push them in a little bit. And the exact distance that they need to be apart is going to be determined by our linear rods that are going to go through these X-in bearings. So we want to actually put this on into place, make sure that that's all where it needs to be as far as the Z-axis smooth rods, and then put the timing belt on. And then use our belt tensioner to get us that last little bit of the belt tension that we need so that this works properly. So that's everything for the X-axis, and that includes this new mechanism that's gonna, you can see how this is gonna work. Once it's assembled, it's gonna push against each end, and that's gonna flip our Z probe up and down. And oh, I didn't even mention the wiring for the Z end stop. Goes through this little slot. This is only about the third time I've assembled this, so I missed that little detail. And then there's a guide along the side here that's meant to hold that wire. You might be able to fit the wire through it. When it prints, it starts as a little tunnel, but this one was like a little too tight, and I don't really need it to go through there anyway. So I trimmed off the bottom, and I'm just going to use it to keep the wire up against this edge. And I'm going to put that right through there. And now this is going to go up and eventually back to the electronics. So there, now it's done. So that is the X-axis.